y'all, today we're going to start solving some two-step equations. So we're going to remember some stuff from 7th grade. So then we can move on to the 8th grade equations. So for today, you guys are going to need your notes. Specifically, we're going to be on pages 9 and 10. You also probably need a calculator. Okay. If you do not have a calculator with you, again, I'll show you guys where to find your calculator. So if you go to Google Classroom and you go to classwork, miscellaneous materials, the link to my website. Again, I would bookmark this if you haven't. And then once the website loads, you'll hit calculators. And I would be using the scientific calculator. I would use this calculator over Google or just typing it in a new tab just because it's very user-friendly and it has fractions on it. So today we are going to talk about two-step equations. We are on page 9 and 10 in your notes, and that should be in your binder. So you should go ahead and grab those. And let's go to went too far. Okay. All right, so with these two-step equations, the first thing, if we were to do this algebraically, is we would get rid of the addition or the subtraction, or these constant numbers that are not attached to the variable. Okay. Then after that, we would use multiplication or division to remove the coefficients or the numbers that are being multiplied by the variable. By doing that, it will isolate the variable and it'll tell us what that number is equal to. So I'm going to show you guys with a bar model, just kind of like a visual way to like come up with these answers using problem solving strategies. And then we'll also do it algebraically, probably what you are used to seeing. But the first thing I always do when I look at a problem is I just look and see, can I figure this out without doing any math? Can I use a problem solving strategy? So right now it's asking, we have 5x plus 2 equal to 12. So that's saying 5 times something, some number, plus 2 has to equal 12. So to me, I like to draw a little picture. So here are 5 x's. And I'm going to write 2 right there. Okay. And this whole expression, these 5 things plus 2, has to be equal to 12. Okay. So if I'm just using my problem solving strategies, okay, if I know that 2 is right here, okay, I know that these 5 x's need to equal 10 because 10 plus 2 equals 12. Okay, then if I think about x's being even and they all have to be the same thing, if I have 5 boxes and they need to all add up to 10, that means that each box would have to be 2. So just using my problem solving strategies, I figured out that x equals 2. Okay, but now what we'll do is we will solve this algebraically, just something that you guys can be used to seeing. So first I'm going to go ahead and write the equation down, 5x plus 2 equal to 12. Okay. So our goal is to isolate the variable, isolate x. Okay, so we like to draw, me personally, I like to draw a line on the equal sign because whatever we do to one side of the equal sign, we have to do it on the other side. So that just keeps me organized. Again, I like to also know, okay, this is what I'm trying to get all by itself. So first we need to see, okay, where is there addition or subtraction? And I see this addition or this positive 2 right here. It's not attached to the variable, so it's not multiplying, so this is addition. So I'm going to undo it or simplify it. And so the opposite of a 2 is a negative 2. Whatever I do to one side, I'm going to do to the other side. Okay, so a 2 and a negative 2 zero out. Okay, then we're just left with 5 x's. And then we just have this math problem, 12 minus 2, and 12 minus 2 is 10. You'll see that it kind of goes along with the picture that we just created. We had 5 boxes, and we know that they have to equal 10. Okay, so now what we're going to do is we're going to isolate the x even further. Okay, we have 5x. So there's an imaginary multiplication symbol right there. Okay, so to undo or the inverse of multiplication is division. So we're going to divide both sides by 5. Okay. 5 divided by 5 is 1. So we're just left with 1x instead of 5 x's. And then 10 divided by 5 is 2. then we can always check our work. That's kind of a reason I like math so much, is you can actually just check to see if you're right. Okay, so I'm going to write 5x plus 2 equal to 12, and we are checking to see if 2 is the right answer. So we are going to plug in 2 wherever we see an x, and then we're going to do order of operations, and if we're right, it should equal this side of the equal sign, so equal to 12. So 5 times 2 is 10. 10 plus 2 is 12. I know I'm right. Okay, so those are just different ways that we can do it. Now, obviously, it could get harder with the pictures, so it is nice to know the algebraic way. All right, so now we're going to talk about some negative numbers. Okay, so we have 14 plus 9m's, and that equals negative 13. All right, so again, I'm going to draw a picture just to kind of help me out. Okay, so I have, this is 14. Let's say this is 14. Okay, and I'm going to just draw out 9m's. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't need that much. Okay. Okay, so 2, 4, 6, 8, 9 m's. Okay, and that needs to equal, whoops, that needs to equal negative 13. Okay, so sometimes the picture isn't very helpful because we have to figure out, okay, we have these numbers that all have to be the same, and we're going to add 14 to it, and it needs to equal negative 13. So we have to think about our number sense. My dog sees something right now. So if we add 14 to something, okay, and it has to equal negative 13, that means I'm really far down, okay? And when I add 14, I still am at a negative 13. So what I'm going to do is I'm going to put a negative 14 with this. So that means that my 9m's, 1, 2, 3, 4, 5, 6, 7, 8, 9. My 9m's have to equal, I'm going to put these together, negative 27. Okay. All right, so now I have 9 equal things, and they have to equal a negative 27. Okay, so I think, all right, well, 27 divided by 9 would be 3, so it needs to equal a negative 27, so let's try a negative 3. Okay, negative 3, oopsie, negative 3 times 9m's would equal negative 27, so I'm probably going to be right. Okay, so the problem solving strategy is just to kind of help you guys visualize what we're doing and what we're trying to figure out. Okay, all right, so let's go ahead and solve this algebraically. Right. Okay, what I'm trying to isolate is this m. Okay, so I think to myself, what do I need to get rid of first? I have 9m's, I have a positive 14. I need to undo or get rid of the 14 with inverse operations. So this is a positive 14, so I'm going to undo it with a negative 14. Okay, and 14 and negative 14 make 0. So now we have 9m's equal, and then we have negative 13 with a negative 14, which would make negative 27. Now we have 9m's, and they have to equal negative 27. So again, we could use our problem solving skills. You could also see that there's multiplication in between a 9 and an m. So we can just divide by 9, divide by 9. 9 divided by 9 is 1. So instead of 9m's, we have 1m now. And then we can do this math problem, negative 27 divided by 9, and we can get negative 3. Okay, so if we're right, we can check. So if we're going to check negative 3, and if we're right and we use order of operations correctly, we should get negative 13. So we have 9 times -3, because we have to do multiplication first before addition. So we have -27. And -27 plus 14 would equal -13. So I know I'm right. Okay, now this one, it is important to kind of see like how we can set this up, problem solving strategies. So what I'm going to do is I'm going to imagine that we have -4x's minus 5. Okay, so when I think about subtraction, I think about making things smaller. So instead of us having 4x's or -4x's, we're actually subtracting 5 from that. So we're actually going even smaller than that. So this right here, okay, I'm going to say that this is 4x's, -4x's, but I'm also taking some away. I'm taking away 5 from that, okay? So this amount right here is the 4x's, the -4x's, and us taking off 5 as well. And that's saying that this is equal to 19. Okay. All right, so now for us to visualize this, we probably need this whole amount because we want to know what 1x is, not a couple x's with something taken off of it. So instead of a -5, what we're going to have is a +5. Okay, so then our new picture is all 4 of these x's, these -4x's, is equal to 24. Okay, so now sometimes it's kind of hard with this visual to see that there are -4x's. So what I like to do is if I have -4x's and it's equal to a positive number, I'm just going to think to myself, okay, what if it was -24? Okay, and if I have 4x's and they need to be -24, they need to be even. So I'm thinking of the number 6 because 6, 6, 6, 6 makes 24. So then it would have to be -6, -6, -6, and -6. Okay, so my guess is going to be -6. Right, so now we can try this algebraically and see if we get the right answer. So again, our goal is to figure out what this number is equal to. Okay, so with this one, I need to worry about these numbers. Okay, this is my answer right now. Okay, and we need to isolate the x's. So we need to get rid of this -14. We need to get rid of this -5, and we need to figure out which one we have to do first. Okay, so the one that is the subtraction, or the one that's kind of further away from the x, this is attached by multiplication. Oops. This is attached by like subtraction. So we're going to get rid of this -5 or this -5. The opposite of a -5 is a +5, or the opposite of a subtraction is addition. So we're going to do that to both sides. Right? -5, +5 makes a 0, and we are just left with -4x. I don't know why I wrote -14x. Okay. And then we have 19 and 5, which make 24. Okay. So now what we need to do is we have 4x's, -4 of them, okay? And we need to figure out, okay, what makes 24, right? So what I did in the picture is I just kind of flip-flopped it. I had 4x's and it needed to be a -24, okay? Either way, we're going to get the same answer, okay? So again, this is multiplication. So the opposite of multiplication is division. -4 divided by -4, we're going to divide by exactly what we see, is a +1. So instead of having -4x's, we have 1x. And then 24 divided by -4 is -6. Okay. If we would have done it the way with kind of like the picture way, having +4x's equaling -24, we would just divide by what we see, which is 4. So 4x's become 1x. And -24 divided by a +4 is still -6. So either way, guys, we're getting the right answer. Sometimes if we're doing the bar model or the problem solving way, it's kind of hard to envision negative x's. So I just kind of flip the sign for it to make sense to me. All right, if we are right, it should equal 19. So negative 4x. We're going to practice. We're going to try with negative 6. Okay. Negative 4 times negative 6 is a positive 24. 24 minus 5 is 19. So I know I'm right. Very cool. All right, so now we're on page 10. These problems are a little bit harder, probably just because they have fractions and people get a little weirded out with fractions. So again, we're going to talk about just kind of visualize this and then how we can do it algebraically. All right, so we have something, okay, over 3, and we think about over or fractions, we think of dividing. So I'm taking something and I'm cutting it into thirds. I'm dividing by 3. And then after I'm dividing it by 3, I'm even taking off more. I'm subtracting 6. And when I do that, I get a negative 12. So let's kind of just visualize what this means. Okay, so I'm going to say that this is n. Okay, so this is n. Okay, but I need to cut it and divide it by 3. So here's n divided by 3. Okay. After we divide it by 3, they want us to subtract 6. Okay. So they want us to take one of these little sections and even take off 6 more. Okay. And then that little amount, oopsie. I don't know what it's doing. All right. Then that little amount, so not even a third of something, and that little amount is equal to negative 12. Okay, so what we need to do is we need to figure out the entire thing. I want to know what n is, okay? And I only know a third of it, subtracted 6. Okay, so first, let's fill in this part at least so we know how much this is. If we know how much this is, it'll hopefully help us. Okay, so if we had to subtract 6, what we're going to do instead is we will add 6. Okay, so then I'm going to redraw my picture. So here's n, and I just cut it into thirds. Okay, and this little amount right here is equal to 6 and negative 12, which would make negative 6. Okay. So now I'm just trying to visualize, okay, I need to know this entire amount. Okay, well, if this is negative 6, and this is negative 6, and this is negative 6, altogether, that would make negative 18. Okay, so if we're right, we should get negative 18 if we do it algebraically. All right. My goal is to get n by itself. That's what I'm trying to figure out. What is this number? I don't know. Okay, so we have division and we also have subtraction. So it's always the first thing I ask myself, what's going on? Okay, it's being divided, it's being subtracted. It's getting really, really small. And when we do that, we get negative 12. So first I'm going to get rid of this subtraction or this negative 6 with a positive 6, which would make a 0. Okay. Negative 12 and 6 would make negative 6. Okay, and then we have something divided by 3, and that has to equal negative 6. Okay, so the opposite of dividing or cutting things up would be multiplying by making it bigger. So we're going to multiply by what we see, which would be a 3. Okay, and then I'm going to do it to the other side. Okay, now some people really struggle with like what's going on right here. Okay, so I always think about, okay, what's the number, the invisible number in front of n? And it would technically be a 1. So right now it's kind of like 1 in, because there's one of it, and we just cut it into thirds by division. Okay, so what we're doing is we're technically kind of like multiplying by the reciprocal. So the reciprocal of 1 over 3 is 3 over 1. Okay, and when we do that, we multiply straight across, or however you guys multiply fractions, we would get 3 n's divided by 3. 1 n times 3 is 3n. 3 times 1 is 3. And 3 n's divided by 3 would be just the 1. Okay, so it takes a lot of time to kind of visualize and understand what's happening right here. But if you have division, we're going to multiply. Okay. So we have 1 n left, and then we had 3 times negative 16, which would be negative 18. And we're right. So, all right. And then one last check. All right, so let's see if we are right. I didn't mean to do that. Okay, so we are going to check negative 18. PEMDAS, we need to divide before we can add or subtract. So we're going to divide negative 18 and 3 and get negative 6. Negative 6 minus 6 is negative 12. Woo woo. Okay. All right, we're going to do 2 more. These ones are probably the toughest ones. So we have half b plus 6 equaling negative 4. Okay, so here's b. Here it is. Okay, but we're not even talking about one whole b. We're talking about half a b. Okay, so I'm going to say that this is half the b. Okay, so here's half a b. Then from there, we're adding 6 to that something. Okay, and that needs to equal negative 4. Okay, so here's half the b, because it's not a full b, it's half a b. And we add 6 to it, so this full amount has to equal negative 4. Okay. All right, so with this one, we could kind of just use our problem solving skills. If I have something plus 6, it has to equal negative 4. That would be negative 10. Okay, just using my mental math and my number sense. Negative 10 plus 6 is negative 4. But if we wanted to kind of think about, okay, this is addition, so we would need to like subtract it away. And when we would subtract it away, it would disappear. And so this amount would be negative 10. Okay. So now we have half a b equaling negative 10. Well, we need the full b. We need all of it. So this would also be negative 10. So if we're right, I think b should equal negative 20. Okay. So now let's try it algebraically, see what happens. Okay. All right, so the first thing we're going to do is when you think about what's happening, we're taking half of something, we're adding 6 to it, and it equals a negative 4, not a positive 4. Sorry. Okay, so we're going to get rid of the constant or the adding or subtracting first. So this is a positive 6, so we are going to subtract 6. That would make a 0. Then we have half a b left over. We have negative 4 and negative 6, which would make negative 10. Okay, so we're almost there. We have half a b, but we need a full b. We need one whole b. So what we can do, there's 2 different ways to do this problem. I'm going to think about it just like how we did the last problem with dividing by 3, like that 1 over 3. I'm just going to multiply by the reciprocal. Okay. So when we do that over here, okay, we have 2 times 1, which is 2. We have 1 times 2, which is 2. So then we're left with 2 over 2b, which 2 over 2 is just 1. So instead of half a b, we have a full b. And then we have negative 10 times 2, which would be negative 20. Okay. So again, I think we're right. Let's check to make sure. So we are checking that negative 20 would equal, when we plug in negative 20, we would get negative 4. Half of negative 20 is negative 10. Negative 10 plus 4, negative 10 plus 6 is 4. So we are right. All right. And then the very last problem is probably everybody's least favorite. But when I learned about these bar models, it really kind of helped me visualize what we're doing. Okay, so let's kind of try it out. 2/3 something, x plus 19 equals 35. So let's start off with x. We don't even have a full x. We only know 2/3 of it. So, okay, so I'm only talking about, I'm gonna change the color. I only care about 2/3 of the x. Okay, so here's 2/3 of it. Okay, and then from there, we're gonna add 19 to it. So 2/3 of an x, so this green part, plus 19, that amount is equal to 35. Okay. All right, so if we know if we add 19 to it, it's obviously going to be, this amount has to be smaller. So you could subtract 19 or just visualize, okay, if this amount is 19, but the whole thing is 35, that means that only these two would have to be 16. Okay, again, only 2/3. So if two of these boxes make 16, one of the boxes would be 8. Okay. Now, again, we're asking to find the entire x. That's what I want to find out. If we figured out that this is 8 and this is 8, well, the full thing would also be 8, and 8, 8, 8 would make 24. All right, let's see if we can figure this out algebraically. Okay. So the first thing we're going to do is we are going to get rid of the constant or the adding or subtracting. So this is a positive 19. So we would subtract or add a negative to it. (35 minus 19 is 16. Okay. So now we need to get rid of this 2/3. Okay. So the way I'm going to get rid of this 2/3 is I'm going to multiply by the reciprocal. So the reciprocal of 2/3 is 3/2. Okay. Again, what's happening right here is we have 3 times 2. We have 2 times 3. 6/6 is equivalent to 1. So now instead of having 2/3 of an x, we have 1 full x. Okay. Now from here, we're going to do 16 times 3 halves. So if you have your calculator, you can do 16 times 3 ABC2. If you don't have your calculator, I would do it on the Desmos. So do 16 times 3/2, and it equals 24. Okay. And then one more check to make sure we are good to go. Okay, so we are checking 24. So 2/3 of 24. Might need to figure that one out. So 2/3 times, so we have to get the right arrow, times 24 is 16. 16 plus 19 is 35. Okay, so I'm not asking you guys to check it every single time, but it is a great strategy. I'm not telling you guys that you have to draw a model every single time, but to me, this makes sense to help me figure out what x is equal to. Algebraically, this works too, but sometimes we get lost in what we're actually trying to find. Okay, so today's assignment is 5 Delta Math problems. We just did 6 together, but on Delta Math, there are 5 that you guys are going to try, and then we will practice some more tomorrow.